This is an example of how to solve a problem with two masses coupled by a tension that is holding them together, just like many examples we've looked at in class or are going to look at in the future. We've got these two boxes, a box of pickles, it's 10 kilograms, and a box of artichokes, 40 kilograms. They're tied together with a string. And what's happening to them? They're sitting on a frictionless surface from frictionlesssurfaces.com, and they're being pulled to the right by a toy backhoe. How hard is that backhoe pulling? With a force of 80 newtons. Let's get the backhoe out of there, just 80 newtons. So what is going to happen? We want to know two things in a problem like this. What will the acceleration of these boxes be is one, and how big will this tension be between the two boxes is the second thing. So, the first question you might ask yourself is, are they going to have the same acceleration? And what do you think? If this string can't stretch, what will happen when this one moves 10 centimeters to the right? This one will have to do what? It'll move 10 centimeters to the right too. So they'll have the same acceleration. So I could just ask, before I begin, if I pull with 80 newtons on 50 kilograms with no friction in my system, then I know that my net force is going to equal the mass times the acceleration. Here the net force is just that external force of 80 newtons, and that'll equal my total mass of 50 kilograms times whatever the acceleration is. So just dividing both sides by 50, we see that the acceleration is going to be 8/5, and there I say to myself, these zeros cancel, 8 over 5. I like decimals, so could I make that over 10? 8 over 5 is 16 over 10, which is 1.6 meters per second squared. So there's the acceleration before we even analyze the system in detail. But things get more complicated when we add other effects to a system like this. So let's look at a methodical way to solve the problem.